Okay, so far we've talked about vertical asymptotes. Now let's talk about horizontal asymptotes. A horizontal asymptote is a horizontal line that the graph gets closer and closer and closer to. So you can have a horizontal asymptote at the right, a horizontal asymptote at the left, or both. Let's take a look at the ones at the right. So let's suppose we have a horizontal asymptote at a level L. That means that out here, the curve is getting closer and closer and closer to the line L. So if you give it a function value that's very, very big, it's going to be close to L. Now, we don't, it could be doing anything over here. Doesn't matter. Over on the right, it's getting closer and closer and closer to L. So we have a horizontal asymptote, if the limit as x gets bigger and bigger and bigger of f of x equals L, we have a horizontal asymptote at y equals L. The vertical asymptotes were at a particular value of x. The horizontal asymptotes are at a particular value of y. Okay. Now you could also have an asymptote on the left-hand side. That's what happens if the limit as x goes to minus infinity is a particular number. Okay. So let's look at an example of a function. We'll start with a trig function that has a limit as you go to infinity and a limit as you go to minus infinity. Let's look at the function f of x is equal to the arctangent of x. Okay. Now you remember that if you have an angle theta here, and this side is 1, then this side is the tangent of theta. So as the tangent gets bigger and bigger and bigger and bigger, the angle gets closer and closer and closer to 90 degrees. So if we call this x, this is the arctangent of x. The bigger we make x, the closer the arctangent gets to 90 degrees. So the curve, well, we usually use radians, so we have it at pi over 2. And if you have a very large value of x, you're going to have the arctangent very close to pi over 2. In this example, it's got another horizontal asymptote to the left, because as you take the limit as x goes to minus infinity, then the angle goes to minus pi over 2. So this is a curve with two horizontal asymptotes, one on the right and one on the left. Now, we've also seen examples of curves with one horizontal asymptote. We earlier looked at the function x squared plus 1 divided by x squared minus 1. What happens as x goes to infinity? If you plug in x equals 1,000, you get 1,000,001 divided by 1,000,000 minus 1. That's really close to 1. So as you go off to infinity, this approaches 1. As you go to minus infinity, it also approaches 1. So this is an example of a function that's got vertical asymptotes at x equals 1 and x equals minus 1, because that's where the function blows up. And it's got horizontal asymptotes at y equals 1 on both sides, because that's how the function behaves as x goes to plus or minus infinity.